Okay, so example number 10 from the textbook is very similar to the basketball problem we just looked at. Suppose a computer chip manufacturer rejects 2% of the chips produced because they fail pre-sale testing. So the probability it's rejected is 0.02. Okay, big mistakes made with making that into a decimal. What's the probability that the fifth chip you test is the first bad one? So the probability of success, P in this case, is 0.02. And it's my fifth chip is the first bad one. Remember, the words first are telling us I have one success on the fifth trial. That's geometric. So if I'm doing this in the calculator, we're going to talk about how to do this in the calculator. I'm going to use the Geomet PDF function. PDF is a single value. My x in this case is 5, and so I put 0.02, 5. And the calculator does 0.98 to the fourth times 0.02. That's what the calculator is doing, but we're going to the Geomet PDF and we're putting in our p and our x. How do we do that in the calculator? Here's our calculator. The menu is second distribution, just like normal CDF. I go up because Geomet PDF and CDF are at the bottom, and then there is your binom PDF and CDF. And so I'm going to find Geomet PDF because I only want a single value. I put 0.02 in for my P and 5 in for my X value, and then I hit paste. I write this down in my calculator, and I get 0.01845. .01845. The second question is, what's the probability you find a bad one within the first 10? That means it could be our first one, plus it could be our second one. So the first bad one is the first one we find. The first bad one is the second one we find. The first bad one is the third one we find, all the way up to the possibility that it's the 9th one or it's the 10th one. So that the first bad one is among the first 10 that we find. So we are adding this up. Now this in the calculator is Geomet CDF. Okay, my probability is still 0.02, but I want to add it up to 10. So this ends up being like 0.02. That's the first one. Plus 0.98 to the 1, 0.02. Plus 0.98 squared times 0.02, all the way up to 0.98 to the 9th times 0.02. That's what your calculator is doing, and there's the benefit of the calculator. We don't have to enter in all those numbers ourselves. So let's look at it in the calculator again. It's in the second distribution menu. Go up to Geomet CDF this time because I want it to add up from 0 to the number I give it. P only gives me one value, so if I plug in 10, it gives me the 0.98 to the 9 times 0.02. If I plug it into CDF, I get 0.02, that number that I just wrote down. Everything is going to add up from 1 all the way to the x that I give it. So my probability is still 0.02, and now my x value is 10. And I'm going to paste that, and we get 0.18293. 0.1829 is good enough. Okay. Move this movie out of the way here. And then lastly, what's the probability you find at least 3 bad ones in the first 10 we examine? Now we are saying if I examine 10, so out of 10, what's the probability that I have 3 or more bad ones? Right, so that's x is greater than or equal to 3. Remember we talked about If x is greater than or equal to 3, the complement of that is 1 minus x is less than or equal to 2. Because I wanted to add 3, 4, 5, 6, 7, 8, 9, and 10. So I need to subtract off the 2, the 0, and the 1. This is the only thing your binom CDF calculates. It does not calculate 3 to 10. You have to do, it only does from 0 to the number you give it. So when I plug that in, my n is my number of trials, which in this case is 10. My p, 0.02, and then what number I'm interested in, and I want it to add up from 0 plus 1 plus 2. And then if I do 1 minus that, that gives me 3, 4, all the way up to 10. So what does that look like in the calculator once again? So it's in the second distribution menu. I'm going to go up. I want it to add up. My question was at least, so I'm using CDF. If it was exactly 3 out of 10, I'm using P for a single value. My trials are 10, my probability is 0.02, and I'm asking it to add up to 2, and paste. And we get 0.999. So there's a 99% chance that you're going to get at least 3. Oh wait, I got to subtract 1, right? All I did was the binom CDF part, so I have to do 1 minus that. This 0.999 is the probability of 0 plus 1 plus 2 of 10. So I want 3, I got to do 1 minus that. And that's 8.639 times 10 to the negative 4. So remember that moves the decimal point 4 times, so 0.000864. So it's really unlikely to be getting 3 or more bad ones out of 10. And that should make sense because the probability of it being bad is pretty low.